Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering, Vedang Institute of Technology. So, we will discuss numericals on bars of bearing section. Okay, before in previous class we have discussed the formula. Now using those formulas we will calculate some numericals. Okay, so here is the section A, B, C, D. Okay, so here the load is different in all three sections. Okay, this is section 1, here is your section 2 and here is your section 3. So here load is different in all sections. So we need to first find out load for these three sections. First, here 50 kilonewton, that is tensile in nature, is given. How we know it is tensile? Because it acts in, it pulls. Okay, it pulls this section 1, so it is tensile in nature. So as here in AB section it is 50 kilonewton, so here also 150 is here. In case of 80, here we have the 50 of AB section. So next going to BC section. Here in BC section we have one compressive force of 20 kilonewton. So as here 80 is present and we got only 50. So we will add these compressive force of 20. Okay. Also, as in case of CD section, here we can see that we got here what? One compressive force, but in this side it is what? Tensile. Here force is not given, as this is for BC section. So this and here the 10 of this 80 kilonewton. So we got what? Section 1 is our what? AB, section 2 is our BC and section 3 is our what? This whole BD section. Okay. So we need to understand the question. What have asked? A brass bar, okay, cross sectional area of 1000 mm square. Here area of the body is given. So area is 1000 mm square. Next, here axial force is given. Here for section 1, now we will calculate the values for different sections, then we will add it. Okay. For section 1, that is your AB, your P is equals to how much? 15 kilonewton, that is in tensile in nature, and length is given, that is your L1 equals to 600 mm. Okay, so P and L1 is given, also area is given. What have asked in this question? Okay, if your Young's modulus is not given, you can take E as what? 2 into 10 to the power 5 Newton per mm square. Okay, it is the constant value of E for metallic body, so you can take E as 2 into 10 to the power 5 Newton per mm square. Okay, so as E is in what? Newton, so we need to change this kilonewton to Newton. We can write 50 into 10 to the power 3 Newton. Okay, we know the formula that del L equals to P L1 upon A1 into E. Okay. Now, by putting the formula for del L1, okay. So, 50 multiply with 600 upon your area is 1000 into what? So, here for 50 we need to multiply 1000. Here 1000 into 2 into 10 to the power 5. Okay. So, now we will cancel this 1000 with 1000, 2 with 50 as 25 here. Okay. So, our value will be 25 into 6 upon 1000. So, your first del 1 is equals to 0.15 mm. Okay. So, to calculate del 2 for what? For section PC. Okay. So, for section BC, as we have calculated, the force is compressive in nature and 20 kilonewton. Okay. So, your P is equals to 20 into 1000 Newton and your area is 1000 mm square. L is given here, but 1 meter. So, we know that what 1 meter equals to, as 1 meter equals to 100 centimeter and 1 centimeter equals to 10 mm. So, 1000, that is 1000 mm and your E is 2 into 10 to the power 5 Newton per mm square. Okay. So, now putting the values for del L2, P2 L2, okay, P2 is our 20 multiply with 1000 and L2 is your 1000, area is your how much, 1000 into 2 into, okay. So, here 1000 cancel, 2 with 20 becomes 10. So, 1 by 10, that is 0.1. So, del L2 value will become what? Here, del L2 equals to 0.1 mm. Okay. Likewise, we will calculate for section BD. So, for section BD, we will take this whole length 1 meter plus 1.20 meter is 2.20 meter. Okay. Next is what? Here 10 kilonewton of compressive load is there. So, P will be how much? 10 into 10 to the power 3 Newton, and your L3 is 2200 mm. Next, your area is already given as the cross section of this brass bar is equal. Okay, so we will take this area, but if this cross section is not same, so we need to calculate area by using those given diameters. Okay, 1000 mm square, and E is already given, that is 2 into 10 to the power 5. Okay. So, likewise we will calculate del L3, that is PL divided by AE. Okay. So, eleven by 100. So, here it will become 0.11. So, your del L3 will be 0.11 mm. As you can see, the change in length values are very minute. Okay, there is not the biggest difference. So, our del L will become L1 plus del L2 plus del L3. From which principle? From principle of superposition. Okay. We need to add 0.15 plus 0.1 plus 0.11. So, our total deformation is 0.36 mm. That is our total elongation of this ABCD brass bar. Okay. So, in our next numerical, okay, here in that, okay, we need to understand the question as it is completely different from that question. Okay, so here axial pull is 35,000 Newton, and here load is constant, but your diameter is different. In that case, your load is different and cross sectional area is similar. Okay, so your Young's modulus is given 2.1 into 10 to the power 6. So, first here the question asked us to calculate stress in each section. We need to calculate stress in first section 1. We can naming it by A, B, C, D. First taking section A, B. What is given data in section AB? Your diameter is given. B is equal to 2 centimeter. First, here as E is in mm square, so we need to convert all these units to mm. Okay. So here 20 mm and your length L1 will become 200 mm. Okay. So here P is equals to 35 Newton. We don't need to convert this, as here is Newton per mm square, in Young's modulus is in Newton per mm square. Okay. So next, what we need to calculate stress, we need P upon A. So to find out area, here by using the formula for circular section, pi by 4 20 into 20 equals to 100 pi. So as we can't find out by using pi, we will take pi equals to 3.14. If you are using scientific calculator, you can put directly pi. Okay. So 100 into 3.14 is 314. What? Stress is in Newton per mm square. Okay. This is the answer for stress value for section AB. Like that we will calculate for section BC. Okay. We will write here for section 1, stress 1 equals to what? 314 Newton per mm square. Okay. For section BC, here diameter is given that what? 3 centimeter, that is equals to 30 mm. We can take pi by 4 into 30, pi by 4 into d square. Okay. Here 225 pi. Here your area will become 706.5 mm square. We got the area value and we have already P. So your stress will become P upon A. So your sigma 2 will become 49.53 for mm square. Okay. As you can see, if our diameter reduces, so our stress increases. Okay. Here 2 centimeter, that's why sigma 1 is 314 Newton per mm square. As here 1 centimeter increases diameter, you can see the decrease in stress value. Okay. So in our next section, section CD. Okay, D3 is given as 5 centimeter, that is equals to 50 mm. So, area 3 will become pi by 4 into 50 upon 50. Okay. So, 625 pi. Here, your area 3 is 1962.5 mm square. Okay. So, trace will become yeah, 17.834 Newton per mm square. Okay, we can write here sigma 3 is our what? 17.834 Newton per mm square. We got 3 sigma values for these 3 sections. So, in our next question, what I have asked here, total extension of the bar. That means we need to calculate del L values. Okay. So, to calculate the del L values, we know that PL1 upon A1 E1 plus PL2 by A2 E2 plus PL3 upon A3 E. Sorry, E is your constant. So, we do have this PA1, PA2 and PA3 values. So, we can write PA1 plus P by A2 plus P by A3 L1 by E, okay, plus L2 upon E plus L3 upon E. Here we have this, we have all these trace values before, so we can put it here and we can calculate by these L1, L2 and L3 values. From these L1, L2, L3 values, another this formula, and then we will get this del L. Okay. So, here this is the easiest calculation. So, you all can calculate by using calculator. Okay. So, here we have, by taking 2 different type of bearing sections, we calculate the numericals. So, thank you.